Okay, let's dive into this. Picture a massive outdoor concert at night. The blinding lights, the chest-thumping bass, the synchronized drone shows. It's an absolute sensory feast, right? But backstage, for the engineers running the whole shebang, it's an extreme engineering Asura realm. Literally a nightmare where physical limits and digital bottlenecks just collide all at once. Today, we're unpacking the physical art demo proposal. Think of this explainer as a global summary of their highly adaptable, selectable physical solutions for managing these massive events. It's wild. Let's get into it. Here's our run of show based on the proposal. We're going to look at the invisible chaos, a massive paradigm shift, audio spatial drones, and 8K visual sync right before revealing the single chip that powers the entire thing. First up, the invisible chaos. The hidden engineering nightmares happening backstage. To really wrap our heads around this, we have to look past the cheering crowd for a second. Backstage, three massive engineering bottlenecks are crashing down simultaneously. First up, audio. Those massive subwoofers draw such heavy loads that they can actually trigger instant power voltage collapses. Then, the drones. You've got hundreds of them up there fighting thermal updrafts and dynamic crowd noise, which pushes environmental interference to absolute extremes. And third, 8K video. Broadcasting massive, uncompressed, high-def files wirelessly requires crazy precision to avoid lag and jitter. Now, the traditional fix is just throwing more high-performance digital DSPs and microcontrollers at the problem. But adding more software just creates fatal clock latency. It doesn't actually solve the physics. Which brings us to the paradigm shift. Choosing physics over code. Now, what's really interesting here is the radical shift the ABN-QSS technical team is proposing. They're saying, let's stop this digital stacking of complexity. Traditional infrastructure relies on brute force numerical iteration, right? And that causes huge lag, often way over 100 milliseconds. But the ABN-QSS version 2.0 analog coprocessor, it doesn't compute with code at all. Instead, it physically relaxes into the lowest energy state based on pure physical laws. It's kind of like water naturally finding the lowest point in a bowl. Because its hardware literally settling into a physical state, the response time is locked in at a mind-bending 16 to 41.5 picoseconds. Zero software, zero bottlenecks. It is incredibly fast. Moving on to the audio revolution and how they go about erasing dead zones. So, how does the system handle those sudden power drops and severe push-pull distortion? Well, instead of running digital software checks, the system maps the amplifier's circuit directly into analog OTA nodes. There are absolutely no if-else software loops here. Instead, it uses a smooth tangent transconductance. Think of it as a physical shock absorber that instantly erases the 0.6-volt crossover distortion dead zone. It just physically smooths out the audio wave perfectly. Let's break down exactly what happens when that heavy bass hits. The power supply dynamically drops, right? Instantly, a mapped physical law called the dynamic magic cube constraint kicks into gear. The very picosecond the voltage drops, the chip corrects the drive voltage to restore massive current thrust. And it does this in exactly 16 picoseconds. To put that into perspective, that is literally faster than a blink. It is a pure, physical restoration of power, not some clunky software patch trying to catch up. Next up, spatial drone art. Let's look at dynamic choreography. Now, let's pivot and look up at the sky. Coordinating hundreds of drones without a central server is a massive headache, but they solve it with something called waiter mode. When a dynamic obstacle pops up, say a person or a rogue drone, it isn't processed as a traditional geometric collision alert. Instead, it creates local physical strain on a 2.5D energy landscape. This literally builds an invisible energy hill in the drone's spatial calculation, naturally repelling the drone downhill and safely away from the obstacle. No central console intervention is needed at all. It's completely autonomous. But remember, these drones are performers, and this physical framework is endlessly adaptable. Enter dancer mode. By simply injecting an external 120 beats per minute rhythm signal, the drone's X, Y, and Z spatial coordinates naturally evolve into synchronized 3D Lissajous curves. They adapt to the music entirely on their own, guided by a mapped universal constant lambda equals 0.085. It's honestly beautiful physics in action. And if you run a Wall-E dance simulation, you'll find that the joints and flight paths actually lock into a steady rhythm, settling into what's called a stable limit cycle. The drones are achieving perfect harmony through physical evolution alone.
There is zero central computing dictating their choreography. They just feel the beat and physically align with it. Now for our final sensory element, 8K visual sync and achieving zero latency. Broadcasting wireless 8K video through a noisy, packed arena leaves absolute zero tolerance for timing errors. Here, the CSDL chip operates directly on the transmission path as an active timing matcher. By using variational principles, these analog nodes instantly calibrate packet jitter, meaning they fix those annoying timing errors on the fly. There's no heavy digital compression and definitely no delay. It just delivers absolute zero latency synchronization between Ultra HD video and live audio. So what ties all this together? Let's look at the universal language, the CSDL blueprint. You might be wondering, how on earth does one single technology solve audio distortion, spatial drone flights, and 8K video all at once? The secret sauce is incredible adaptability through a unified framework. The exact same 4 physical parameters map perfectly across these entirely different engineering domains. Take alpha, which represents stiffness. It dictates pixel drive strength in screens, but also handles transmission power for the drones. Epsilon is adaptability, managing ambient brightness on one hand and obstacle repulsion on the other. M is the global conservation sum, keeping track of total pixel charge or total synced drone states. And finally, tau is the system response time, managing how fast a touchscreen responds or how quickly video jitter is buffered. It is the exact same universal language, seamlessly adapted to entirely different applications. So the crucial point is how we actually deploy this. To make this globally available and rapidly deployable, the architecture is packaged into a standard JSON file. But, and this is a big but, this isn't your standard software configuration file. It is literal hardware DNA. Burned into the chip via I2C, it physically sets the chip's starting biases and capacitances. It fundamentally alters the hardware's metabolism, so it perfectly matches that specific concert environment, or really whatever extreme environment you need to place it in. Bringing it all together now, the climax, a single chip revolution. Prepare to have your mind blown. Every single one of these extreme calculations, the massive power drops, the drone obstacle evasion, the video jitter correction, they are all being executed simultaneously by the ABN-QSS version 2.0 analog chip. And it does all of this while drawing less than 50 milliwatts of power. That's a fraction of what a single LED bulb uses. Plus, the whole thing occupies just 1.5 square millimeters. We're talking about a highly adaptable system-level revolution built from the physical ground up. Which leaves us with this final crazy thought. If a single 1.5 square millimeter analog chip can perfectly orchestrate the incredible chaos of a 10,000-person physical event just by letting physics do the heavy lifting, what other unsolvable digital bottlenecks out there are simply waiting for a physical answer? Are we finally hitting the hard limits of our digital infrastructure? And is a return to analog truth the real way forward? Thank you so much for joining me on this explainer. I really hope this sparked as much curiosity for you as it absolutely did for me.